Alright, welcome back. Let's do another video here. So again, remember, this is the dimension of the slab, right? There's a little preview of it. So my slab is 120 by 72. It's 3 centimeters thick, which is 1.181. Again, material does not affect the program. I'll put a description, 1, 2, 3, again, and a file name. Okay, I'll just call it new 2. Oh, new 2. Save. Okay. Alright, again, that's our slab. Custom Machining Wizard. Okay, are you going to make your own drawing, or are you bringing in a CAD drawing? I'm going to make my own. Alright, there's my slab. And again, I'm in this drawing wizard, which is a basic CAD package. Again, I got all my tools for moving, chamfers, copying, snapping to endpoints, midpoints, okay, intersections, dimensions, everything. Alright. So let's make a rectangle again using the 4-line method. A line. First point. I'm going to turn on ortho. Again, ortho means whenever I make a line, it'll only be straight X or straight Y. I'm going to snap to this endpoint, and I'm just going to move the mouse in that direction. And I'm going to type in 60 inches. I'm going to move the mouse up, 36. Move the mouse over, 60. Move it down, 36. I'm done. Next. Alright. Again, this looks like it's being cut counterclockwise. Again, where do you want your blade? Do you want your blade on the left side of this arrow or the right side of this arrow? It looks to me like we want the right side. All right. Next. Finish. Okay. This is what I want you to see here. These dotted lines are where the blade is going to come to. So I am going to actually be cutting, if I just leave this like this and cut this, I'm going to be cutting into this slab. How much is that? Well, it depends on the diameter of your blade. An 18-inch diameter blade, you could be approximately 5 inches. So again, if I wanted to draw another part, I would need to leave 5 inches between them. Well, I don't want to do that. I'm wasting a lot of material. I would have to start with some type of optimization. Okay? So I wanted to talk about that now. Machining. Utility. Let's go to disk machining, manual optimization. Okay. What do I have here? I got number 1, number 2, number 3, number 4, and again, 1 start, 1 end. There's 1 end, 2 start, 2 end, 3 start, 3 end, 4 start, 4 end. Okay. And I got all these other things here. We got an A, we got a B, we got a C. All right. I have an outside corner here, all right? And I don't want to waste 5 inches. Okay. What we can do with the software is we can have the blade plunge down on the Z-axis. So instead of losing 5 inches of material, I'll only lose perhaps 1 inch. Again, do I have a 16-inch diameter blade or an 18-inch diameter blade? So, 1 start. Again, this is the end here. This is the end of my slab. I really don't have to do anything here, right? But over here, yes, I don't want to go out all 5 inches. So what I'm going to do, for an outside corner, I'm going to select a C plunge bottom. Okay, so what that means, it'll make sure that this part is cut right off so I can pull this piece out of the slab. I'm going to put a C. And now to start, I'm going to put a C. To end, a C. 3 start, a C, and that's it. That's all I need. Extra depth is going to go 2.5 inches down. Now again, this depends on the diameter of the blade. Remember, you have the blade, and then there's 2 flanges that sandwich the blade onto the arbor of the motor. I'm going to explain tolerance later. I'm going to now apply optimizations. Now look here. See here? I'm only going to be violating my slab by a little bit. But I can remove this piece from the slab and not have wasted 5 inches of material, okay? So again, what I did is I picked the points and I chose C. C is going to be for an outside corner. B will be for an inside corner, okay? All right, let's hit OK. Let's go to sort machinings. Set default cut directions. So again, there's number 1, there's 2, 3, 4, 5, 6, 7, and 8. Now again, I can move these. I can manually move these around if I want a specific order. Let's go to OK. Let's go to Build, ISO, Compile. I am done. Program is made, right? View, Isometric, Fade. What is that? I can change the color, the transparency, excuse me. And let's hit play. Okay, I'm cutting. Machine rapids down. See that? There was a plunge. A plunge. And now a cut. Cut. Plunge. Plunge. Okay, we're done. So we're done. But again, if you had many pieces on here, maybe you want to keep everything going in one direction, and you can do that. We would go back to machining. We would go to sort machinings, and I could move these around. So I had 1, 2, 3, 4, 5. Maybe I want this to be next, not 7. So I can move those, right? From ATMs to airport check-in kiosks, NCR Solutions run the everyday transaction. 5, 6, 7, 8. Let's hit OK. Now, you have to build again. Build, ISO, compile. I just made a new program. View, isometric. Let's play. All right, there's my y-axis cut. Plunge, plunge, cut. Cut, plunge, cut, plunge. All right, so as you can see, I could move the order of operations around all I want. Again, machining, sort machinings, and I can move them around. But remember, you have to build a new program again. All right? All right, so again, in that example, I moved some of these machinings around. All right. If I made a mistake and I want to start over again, I would reset disk optimizations, and I can start over again. Next video, I will go over that some more.